So today we're going to be talking about the JavaScript native interface, which is actually one of the core integral pieces of Google Web Toolkit. This is kind of a different presentation than any I've ever done before. And in fact, I have very, very, very few bullet points, unlike any things I've done before. So hopefully it'll turn out well. If it doesn't, sorry, I'm kind of going on a limb here. This is a little overview of what we're going to do. So let's jump right in. So this is a basic snapshot of what the JavaScript native interface entails. And in a nutshell, it's writing JavaScript code directly into your GWT application. So obviously, the big benefit of GWT is that you write all your code in Java. The compiler compiles it in JavaScript. So most of what you would do is in Java. But sometimes, for various reasons, you may want to drop down to JavaScript and sort of write some JavaScript by hand. And JavaScript native interface, or JSNI, is what lets you do this. We tend to think of it as sort of like analogous to inline assembly in C. So the basic idea is you just declare a native method, use our specially formatted comment, and then put your code inside of it, just like in this example. So in this simple example is like basically the smallest way you could possibly write hello world in GWT. And it's just by writing this handwritten native method to show an alert up on the screen. This is actually an abuse of Java syntax that we sort of took advantage of. Native is a keyword in Java that probably most of you are familiar with. And in Java land, it actually correlates to the Java native interface, which this is modeled on. Java native interface, JSNI, is where you can write code for Java, but in C++, and you sort of interoperate with some low-level operating system type stuff is often what this is for. So this is very, very analogous to that with JavaScript native interface because you're actually interoperating with the browser. So you use the native keyword, and then after that, you'll notice this thing that looks like funny curly braces is actually a Java multi-line comment, so that the code that you write inside of it is invisible to a compiler like JavaC. This is what allows IDEs to just ignore this and continue on parsing your code without us having to invent things that would be extensions to the Java language. Yes?
Can you have it return something?
The question was, can you have it return something? And yes, we'll see a bunch of examples of that. All right, so one of the main reasons you might want to use JSNI is to talk to the browser APIs directly, because there really is no API for talking to a browser directly in Java code, right? The API for all the browsers is in JavaScript. If you want to talk to it directly, you have to use JavaScript to talk to it. Now, there are APIs in GWT that we have invented, but as far as there being some kind of API for Java, there's not one, so this is how you do it. In this example, say you wanted to write a little function to inject an external script in your application. Here's an example of how you could do it by manually creating a DOM element, setting the source on that script tag, and then hoisting it up into the body. To be honest, though, that's kind of a contrived example because all the APIs you would need to do that are, in fact, present in GWT. But there are things that we probably have left out. So, if you can't find the API you need, this is what prevents you from being boxed in. Bruce has mentioned in his talks before that we're not out to sort of constrain you or put you in a box. And this is what allows you to do basically anything in GWT that you could do in JavaScript, because if you ever run into a roadblock, you can always just drop down to the native level and do whatever you need to do. Going back to the slide before, you may notice that the code here looks maybe a little clunky compared to what you might write by hand. But actually, we're working on some things to make that look a little nicer. So hopefully in the future, there will actually be a JavaScript way of sort of doing this in a little nicer manner. Another reason you might want to do this is simply performance. There's some things that browsers can do really well and really quickly that you can't necessarily do in Java very quickly. So to give an example, this is a very naive implementation of the string.valueOf method. In fact, I believe this is very similar to the code that actually shipped in GWT 1.0. And as you can see, the algorithm here, which is straight Java, is just to do a series of string concatenations on the characters that are in the array. The problem is this creates a ton of intermediary objects, and it ends up being really, really, really slow. Well, in GWT 1.4, we found that there was a nifty trick you could do. We found that the JavaScript method string.fromChar code could actually take multiple arguments. So all you had to really do was use a trick to essentially, if you could pass that entire array as a series of arguments, it ends up being really fast. And the JavaScript function that does that is apply, which essentially takes an array argument and sends that into a function as if it were individual arguments instead of the array. And actually, that allowed us to see a huge, huge performance increase on string value of character array. You probably can't see the numbers too well on the graph up there. But you'll notice a couple of things that first, just by looking at it, the original implementation was something like O of n squared on IE. So in other words, the bigger the character array, the longer it would take super linearly. And then just in absolute terms, it's just a huge difference. So you can see the numbers here. All right, so JavaScript native interface has actually a lot of rules associated with exactly how you can pass types in and out. And we'll talk about the rules a little bit, and then I'll talk about kind of why. All right, so in a nutshell, most of the type, it's sort of intuitive how this works, and you can find these rules in the GWT documentation. But essentially, if you have something like a numeric primitive, that correlates to a JavaScript number. If you have a string, correlates to a JavaScript string. Boolean, JavaScript, Boolean. A Java object in JavaScript, there's not necessarily a lot you can do with it without using some special syntax, which we'll go in later. But for most purposes, it's kind of an opaque object to you. And then there's a magic type, JavaScript object, which represents something that is a just plain old raw JavaScript object, coincidentally enough. And we'll go into more detail about that later. But the thing to sort of realize here is that when you make a transition of values between Java and JavaScript, there's a definite junction point. So, and this can happen a number of ways. It could be that you're calling a JSNI method, passing in a value of a declared type. It could be that you're returning a value from JavaScript into Java code, and again, you have a declared type of variable. So what's on the left-hand side here in the chart is like the declared type, and that is associated with what the JavaScript type needs to be. And that kind of cuts two ways. One, it means that if you're passing a value into JavaScript, this is the type that it will come as. So if you pass a string in the JavaScript code, it will be a string. If it's an int, in the JavaScript code, it'll be a number. But it also represents what you need to make sure you're passing back into Java code. So the compiler cannot analyze what happens inside of your JavaScript code. This is the whole reason for using Java and a compiler and static type system and all that. So it's really, the onus is on you as a developer when you're writing hand-coded JavaScript to make sure you pass back the right type. And we'll talk about why that is. So let's look at this example here where I'm calling a native method that says I'm going to return an int, but in fact it returns a string. Can anybody guess what this code might do? Yes?
It could pick up some number of bytes and attempt to interpret them as a numeric type. Or it could just fall over.
It could fall over. It could do a number of things. In this specific case, what happens is the number 22 gets alerted. Now, why would that be? Because when you translate this into JavaScript, oops. Sorry, looking for the right slide. when you translate this into JavaScript, this just becomes a simple function call that returns the string 2. And in this value coming out of this getNumber call goes into the variable slot that you declared of type int. But in the compiled JavaScript, there are really no types, so this doesn't cause an error or a problem or anything like that. It's just a value going into a declared variable slot. And then when you do something like an add operation, which should have been to add 2 numbers in your Java code, all of a sudden it's doing string concatenation. Now, the reason that this system generally works is that as long as you stay in Java, the compiler will ensure that all of your types are correct in all the places it could be correct. But again, the moment you drop into JavaScript, the compiler loses the ability to validate what you're doing, and it's up to you as a developer to make sure that you're doing the right thing. So in this case, passing back a string when you said it was an int causes undefined behavior because you've gotten outside of the compiler's Java type system. Now, all is not a loss because fortunately, hosted mode, we do have a lot of checking code in. So if you tried to run this in hosted mode, what would happen is as you try to return from the getNumber method, a hosted mode exception would get thrown. And hosted mode would complain that you tried to pass back a string when you declared it to be a number. So this is one reason why using hosted mode is valuable. If you were to look at sort of a model of how hosted mode works versus web mode, and you guys may have seen a slide like this or had this talked about in another session, but essentially when you're running in compiled mode, which is the right-hand side, everything is JavaScript. It's JavaScript, JavaScript, JavaScript all the way down. And when you pass values back and forth, there's no kind of checking or anything like that that happens or automatic conversion or anything like that. It's just values get passed in and out. In contrast, on the left-hand side, in hosted mode, you actually have layers where it's Java running, and then you'll have another layer of stack frames where there's JavaScript running inside the browser, and then maybe even a sandwich where there's other Java code running all on the stack at the same time. Well, these values have to get passed in and out of Java code into JavaScript and back and forth, and there's all this sort of nasty marshalling that goes on behind the hood that you may never guess because it just kind of works magically to the developer. But in fact, there's a lot of glue that goes on there, and one of the things we do is double check all the type information to make sure that you're doing the right thing, because this is really a runtime check. Again, it's not something you could ever check statically because it's JavaScript code you're dealing with. So again, it's good to use hosted mode when you're doing this because it will do that validation for you. Now, in theory, we could have done some validation in web mode. Like, we could emit some code at every call boundary from Java into JavaScript and say, okay, let's verify that the value in this argument matches what you declared it to be. And it's possible that in the future we could add some kind of debug mode that would do that. But in general, we've tried to take the tack of doing the most efficient thing for correct code. So the idea would be you use hosted mode to get your code correct, and then when you compile into web mode, it does the most optimal thing for correct code. And we've not really made an emphasis on optimizing that incorrect code behaves correctly incorrectly, if that makes any sense. Okay. I said earlier that Java objects, when passed into JavaScript code, are opaque. And to some extent that's true, but we invented a special syntax for making them less opaque. And essentially this is, to some extent, an extension of JavaScript because we use this funny @ symbol here, which is actually a syntax error in JavaScript. It has no legal value. So, but this is great because it allows us to hijack the JavaScript language to add features that are very useful. So in this case, what I'm doing is this JSNI identifier goes from the @ symbol here right after the this dot out to the right in front of the square bracket. It's basically what's green. And what this is it's basically saying, I'm making a field reference into Java code. And the object on the left-hand side of this identifier is some Java object that has this field. And this looks kind of spammy. You notice we're declaring like the class, the package name, and the class name, and the field, and all that. Well, that's because obviously the compiler has no idea what that value is. There is no static type information. So you are essentially asserting that the thing on the left-hand side of the dot is a Java util array list, and that you want to access the array field inside of there. And again, in hosted mode, if you screw this up, you'll get an error message. But in web mode, you'll get unpredictable behavior, which is always a good thing. So this is actually an example taken out of our array list class, which is how we implement part of the array list itself. So you can also make method calls, which is really useful. So here's another method taken straight out of our JRE. In this case, I think it came out of HashMap. And what this does is you're iterating through a native JavaScript object, and everywhere there's a key, you're wanting to insert its value into a set. Actually, no, sorry, you want to insert its key into a set. So what this is doing is using the JavaScript, sort of their version of enhanced for loop, although they had it all along. The for in construct, iterating through, and then calling set add repeatedly. And one thing I want to mention about this slide is you'll notice this crazy ljava/lang/object here. The reason we require that is so that overloads can be disambiguated. Because essentially, you could imagine that in Java, you could have 4 different functions named add that had different argument counts or argument types or things like that. And as a matter of error checking and wanting to overspecify rather than underspecify, we just ask that you give the full thing, so that if you were to go back and add, even if there's not necessarily more than one add method in the class, it's better to do this so that if you go refactor and add another add method, all of a sudden you're not calling a function that you think you shouldn't be calling. Okay, so I haven't really gone into detail, but basically the syntax for what goes inside the parentheses is equivalent to the binary syntax that's actually used by normal JSNI. So primitives all have like some capital letter that represents it. So like I think integer is I and Boolean is Z, and there's it's in the doc. You can find out what those types specifically correspond to. And objects are done this way, and with the L and the semicolon at the end to say that it's an object type. And finally, you don't have to use those JSNI identifiers just on instance methods or instance fields. You can also use it to refer to static methods and static fields, which can also be a very useful technique, either for referring, in this case, in this example, it refers to a constant, but you could use it for an event handler to refer to a static method to call back into. There's any number of things you can do with this. Okay. Problem. GWT code has a number of ways it can be deployed. One way it can be deployed is to be put inside of an iframe and therefore encapsulated from the rest of the page. This is actually the normal deployment for GWT. Typically speaking, this is what happens. You have an outer HTML page, and then you have a little iframe that loads up your GWT code in the background, and then it all runs inside this protected environment in the iframe, but manipulates the DOM inside of the outer page. On the other hand, new to GWT 1.4, there is a mashup mode. And in this case, your code is actually running in the top-level page, and this is the reason we did this is for to enable cross-site sort of mashup type scripting. But the point I want to make here is that if you were to simply refer to the window and document object in your JS code without regard to where your code is actually running, there are cases where you would get the wrong window in the wrong document. So if you're trying to, let's say you're running inside of an iframe, if you just said like, window.body.appendChild, or sorry, document.body.appendChild, you would actually be adding elements to the iframe in which your code is running rather than the outer page that you're really wanting to modify. So GWT's solution to this is a couple of special variables that are available in JavaScript code, $wind and $doc. And anytime you're handwriting a native method and you need to refer to the window or the document, just use these variables and you'll be sure that no matter what the deployment scenario is, they'll be set up to be the correct window in the correct document. Okay. There's also the small problem of exceptions. Not that any of you would ever write code that throws them. But suppose you did. So the question that this slide asks is, what happens if you're running some JavaScript code and an exception gets thrown? In this case, we have a variable x that we never initialize. We call x.foo inside a native code. This exception gets thrown, and it gets caught in your Java code. What type is that? Well, it can't be any real Java type because there's nowhere for it to have been constructed, if that makes any sense. You know what I'm saying? Like if you throw a cast class exception or the sort of implicitly defined exceptions in Java, those have sort of well-defined semantics and you're sort of coming out of Java code. But when you're coming in the Wild West of JavaScript code where this exception could be really anything related to the browser, we had to invent a special exception type called JavaScript exception, incidentally. And this particular class has accessors for finding out more about the JavaScript type of that exception and description and things like that. But just know that when you get exceptions thrown out of JavaScript, that this is the type that they'll generally come out as. Another sort of subtle point as far as exceptions is that if you catch a Java exception in JavaScript, there's some funkiness that goes on. And on some browsers in hosted mode, the identity of that thing may not quite be exactly what you're expecting. So as a general rule, we would suggest that you try to catch Java exceptions in Java and JavaScript exceptions in JavaScript and sort of let them handle their own exception handling. Yeah. But we do have it set up correctly so that if you throw a Java exception through JavaScript code and back out into Java code, then all the types will be right and the identity will be what you expect it to be. And that's what we call exception sandwich. Okay. Can anybody tell me what this code does?
Yeah. Just throws up an alert that doesn't display anything at all?
Close. The guess was throws up an alert that doesn't show anything at all. In fact, if you declare a native method and you don't return a value, just like in JavaScript, the value that you actually get is undefined. And this code will actually throw up an alert that says undefined. Now, it's worth asking the question, why do we get inside this if statement at all? We have a guard, we say string s equals get string, and then we do a null check and conditionally do the alert. So why would we end up running this code if we did our own null check?
Isn't that because JavaScript's undefined isn't necessarily Java's null?
Correcto mundo. As a matter of fact, I lost a slide somewhere. There we go. As a matter of fact, undefined is not triple equal to null. It is double equal to null, but it's not triple equal to null. And these are distinct things in JavaScript, which is one of the reasons we love it so much. In fact, double equals means equality in JavaScript, whereas triple equals means identity in JavaScript. And those are most often the same thing except when they're not. And in this case, they're not. Because undefined, again, double equals null, but does not triple equal null. So what happens is when we translate this code, when we generate this code, this is sort of what the generated JavaScript might look like. We actually generate the identity version when we're checking against null. So why would we do that? Well, it turns out that not using identity has some very unfortunate consequences, as you guys may be able to tell by looking at some of these equality conditions here. Namely, that if you compare an object to a string with double equals, it decides to coerce the object into a string and do a string comparison, which is not what you want when you're doing a Java identity test. So again, we represent nulls in Java as JavaScript nulls and objects, as objects. And if we were to do a double equals identity test on all objects, we'd get into this weird string case. But then doing triple equals on identity tests gets us into this weird undefined versus null case. And that's why we had to make the rule that no undefines are allowed in Java code at all. It is totally illegal to ever pass an undefined into Java code. And just to kind of hammer in the point, this is sort of why. You can have triple equals identity testing. You can have string primitives and objects being able to be used interchangeably. And you can have undefined and null being used interchangeably. And any two of those you can make work, but not all three at the same time. And the design decision we made early on was that triple equals identity testing was really important because identity testing is generally much faster in JavaScript than trying to do equality testing, and you don't get the weird corner cases. So that was really important because that really just kind of needs to be fast. String primitives and string objects. This is a really subtle point, but in general in JavaScript programming, you will almost never know whether the thing you have is in fact a JavaScript string primitive or a JavaScript string object. It's very difficult to tell them apart. And to even write the code to try to tell them apart will slow your app down. So we designed GWT in such a way that anywhere in the JavaScript code there's a string. It can either be a primitive or an object, and it doesn't matter. The code will simply work. And this is a sort of a very important invariant because if we didn't have this, we'd have to do all this crazy wrapping and unwrapping and making sure our strings were what we thought they were in a bunch of weird cases. So the one we sacrificed was undefined versus null. You'll find this, in fact, there's a common idiom we tend to use in our DOM code that if you have something that may or may not return undefined, you essentially use this little ternary operation to turn that into a null. And okay, so to kind of explain the idiom, this is basically this seems dumb on the face of it because you're saying if the return value is null, then return null. Otherwise, return the return value. But the reason this actually works is because, again, undefined double equals null. So if the value happens to be undefined, then you trigger the condition and end up returning null. And this keeps undefines out of Java code, which keeps everybody happy. But all is not lost. Again, if you run hosted mode and you happen to declare a method which needs a return value and returns undefined, hosted mode will kindly throw you a hosted mode exception to tell you that you need to get your stuff together. JavaScriptObject. This is one of the key pieces of GWT right here. All right, suppose we have this class button, and we actually need, in JavaScript, to create some button element and then do something with it. In this case, we're going to hold on to it. We may add it to the DOM later, give it a parent. We may set its style. We may do all sorts of things to it. But sort of philosophically, like, what is this thing that we're holding on to, right? I mean, if you think about it, there's got to be some class element somewhere, right? But obviously, its constructor never got called because we didn't create it. Somebody else did. It got created in native code. It's a native JavaScript object. So we have this thing that's not really a Java object, and we're kind of passing it around and doing stuff with it. And that's essentially what JavaScriptObject is. It's sort of an opaque handle that you can play with in Java code that represents some native JS object. All right, so this is what the text at the top of the JavaScriptObject class in GWT says. And I'll read it out and then kind of talk about it a little bit. An opaque handle to a native JavaScript object. A JavaScript object cannot be created directly. JavaScript object should be declared as the return type of a JSNI method that returns native non-Java objects. A JavaScript object passed back into JSNI from Java becomes the original object and can be accessed in JavaScript as expected. Then there's this sort of warning at the bottom that got clipped off, which is meant to inspire fear, that says subclassing is not supported except for the existing subclasses. Or in other words, we're going to use it, but you can't. No, but seriously, the reason for that warning is that the JavaScript object's sort of rules and specification, I wouldn't even at this point fully classify as being pinned down. And the reason is, so we've basically wanted to kind of leave it open so that we could sort of do the most efficient thing we knew how to do, but be free to evolve it to do sort of more sophisticated things, provided we could keep an efficient implementation under the hood. So the specification for this is, again, still kind of evolving, and hopefully in the future we'll be able to even do some more powerful things with it than you can do today. Are there any questions about sort of the very mouthful description that's documented here? All right. So you guys all understand it perfectly?
Got the mic. Ready questions?
We're not done yet.
Okay.
But, I mean, if there are any questions.
I don't need the mic. So we already kind of have a way of doing JavaScript objects if you look at, I guess, Live Connect in Mozilla-derived browsers, where you can instantiate Java directly inside of JavaScript. And did you look at kind of the model they use in your kind of design of the JavaScript opaque object?
So the question is, Mozilla has a Live Connect API, which enables sort of a direct communication between Java and JavaScript code. And the question is whether we looked at that at all when we were modeling this. And the answer is no. Because our goal was to compile down to JavaScript exclusively so that everything would be JavaScript. So, worrying about sort of the bridge between real Java in a browser and JavaScript wasn't really on the radar. So let me talk real quickly about the existing subclasses of JavaScript object, which you're not allowed to add to. I'm kidding. You can add to it if you want. The main reason the warning is there is so that if we do have to change the rules and your code breaks, you can't blame us because we told you not to do it in the first place, right? So it's just kind of a, you're a little bit on your own. But there are some very useful existing subclasses. One of them is element. The other is event. And we'll see some examples of them. But basically, element represents a DOM element, and event represents a DOM event. And the reason we decided to model these as JavaScript objects directly is for efficiency. Because we pass these back and forth between Java and JavaScript all the time in GWT code. We create them in JavaScript, pass them into Java, do a bunch of stuff with them, pass them back into JavaScript. And that needs to be very efficient. So if those were sort of wrapped or had sort of inefficient APIs, it would really slow down GWT. So the last point I want to make here is that this is a very special class. There's special support built into it, both at the compiler level and in hosted mode. And it's really treated very magically, and all of its subclasses. So the reason all the stuff I'm talking about works is simply because we built first-class support for this into GWT. All right, so what kinds of things can you do with it? As I mentioned, this is an element. And it represents, basically, for those of you not super familiar with JavaScript, any sort of piece of HTML layout, like a button or a div or a table or anything like that, can be represented as an element. And so we modeled element as a JavaScript object to expose it in Java code. And one of the things we did was we implemented the Java toString method. And the reason we did that is because when you're debugging in an IDE, it would be really nice if you could just click on an element in your IDE, in your debugger, and have it show you what that thing is. So we decided to implement this as dom.toString, which under the hood on most browsers is inner HTML, which is actually pretty useful because that way if you click on a button, you get something like, angle bracket, button, class this, yada, yada, yada. Really useful stuff. However, this raises some interesting issues. If you look at the implementation of onModule load here, If you look at the implementation of on module load here, you'll notice that we create a button, we assign it to something with a strong type name of element, we call toString on it, and then we alert whether or not this thing is actually an instance of element or not. And these are all things that you would expect to work. But if you step back for a moment and think about what this really means in translated JavaScript, it kind of begs the question of how this could really work. Now in this case right here, it seems pretty straightforward, right? We have an element, we're calling the toString method. Okay, we know what that is. That's this element.toString up here. Okay, so we know how to handle that. And obviously it's an instance of element because what else could it be, right? So there's some, you could argue, there's some static analysis you could do to figure this stuff out. But to throw a monkey wrench in the works, let's say you have this R&D method that randomly returns true and false. And you execute this following code. Okay, so now it's a harder problem, right? Because at the point where you are calling toString or doing an instance of, you really don't know what that thing is. Like, there's simply no way the compiler could possibly really know what that is. And if the compiler can't know, but it still needs to implement this, that means there's got to be some kind of runtime type information. So how do we do this? You could imagine that we have a function called wrap, and that when you return a JavaScript object out of JavaScript code, bring it into Java code, that what you're really doing is calling this wrap function, which adds a little bit of metadata to that JavaScript object so that we know how to deal with it correctly in Java. Does that make sense? Okay. So this is actually not quite what happens. What actually happens is we don't wrap it right at the point that you return it from JavaScript. Because if we did, that would mean we would always have to wrap it. That would mean that the moment you brought anything out of JavaScript code into Java code, we'd have to mess with it. And we don't really want to do that. One, because it's inefficient. And two, because it's inefficient. So what we do is we actually defer this wrapping until we get to the point where the compiler is about to lose static type information. So in this case here, you'll notice the wrap correlates to where we are about to assign this element to an object. And what I call this is implicit upcast. Basically, you're loosening the type of the element, so the compiler very quickly saves off some information so it can remember what it was. Then it can correctly implement toString and alert. Instance of, sorry. All right, so the takeaway from this is when using JavaScript objects, they can be zero overhead if you do it right. We don't wrap them in anything else in web mode. There's crazy stuff that happens in hosted mode, but in web mode, it's very efficient. The rules are not quite pinned down, but it's probably worth, for certain kinds of applications, going ahead and using this because it is so efficient, and it probably won't break too much if we have to change the rules. New to 1.5, you can also declare native instance methods on JavaScript objects, which is really useful, and I'll show an example of that in a little bit. Using final instance methods will reduce the amount of runtime type information the compiler has to add, which will speed up your app. So you should avoid true polymorphism on these things when you can, and prefer to use final instance methods when possible. And then finally, avoid the implicit upcast because they cause wrapping. All right, a few practical examples. GWT uses this for all kinds of things. As I mentioned earlier, everywhere we really hit the browser, we are actually executing JavaScript that generally was written by hand in these very leaf methods. So for JRE emulation, DOM stuff, XML HTTP request, history timer, all the things I have listed. And all these are really good examples. If you're looking for just examples of JavaScript handwritten methods, go to these places and look, and you can see all of our implementations right in the source code of what we're using it for. Another thing we use it for is RPC field serialization. Our RPC generator, and there's other sessions on RPC, needs to be able to generate a class that can serialize the fields of an object. All right, so that's the bottom class here, person field serializer. And one of the methods it needs to implement is the ability to get or set the description on the type it's bound to, in this case, person. However, as you may see, the fields in there are private, which means that you can't just write an accessor like that in a different class because you end up with a compile time error. So our solution was to use what we call the Violator Pattern. And this is using JavaScript code with the JSNI identifiers to basically bypass access restrictions. And it's just kind of a fun thing that sort of fell out that we bumbled into. Another interesting thing you can do is JSON parsing. So let's say you have a structure like this. Let's say this is the result of some web service call that gives you information about some Flickr album, right? And so this is just plain old JSON. Well, it turns out you can use JavaScript objects to do zero overhead JSON interop. So you could imagine that you have this album, you add a getName and getURL method, you implement those as just this.name, this.url. You implement a getImageCount, and an accessor for getting individual images. By the way, I need to qualify this by saying this is all stuff that will be implemented in 1.5 and does not actually work in 1.4. So keep that in mind that, come back to this when 1.5 is out and you can do all this cool stuff. And then you implement the image itself and so on all the way down. Other cool stuff you can do beyond JSON, if you're actually working with objects that have methods, like say you're integrating with some external JavaScript API, you can just call methods on them. And the interop will do what you would expect it to do. And there's some examples of this you can find on like some of the libraries that wrap Scriptaculous or Dojo constructs, or there's Maps API libraries and things like that. These also offer some really good examples on how you can interop with JavaScript external libraries. And you can even do some crazy stuff like implement callbacks that call back from the JavaScript code back into your Java code using closures like here. Finally, just some tips on appropriately using JSNI. If you can, use Java is the first thing. For all the reasons that you're using GWT in the first place. I can't tell you how many times I have written a bug in a 3-line JavaScript method. I kid you not. Like 3 lines of JavaScript and I write bugs. So I try to stick to Java whenever I can, so at least I get the compiler to help me. And I'm really not making this up. Secondly, the more of your code that's in Java, the more the compiler can do for you. The more it has static type information, the more it can optimize, all this other stuff. So instead, you should try to write most of your logic in Java where you can, and just try to write the very leaf methods, just sort of exactly what you need out of JavaScript at the very tip. Use JavaScript to Java references sparingly if you can, and really the main reason for this is whenever you go back and forth between Java and JavaScript, the compiler kind of loses the ability to propagate type information. So if you can avoid doing that, you keep the compiler's correct type information in more of your code, which enables better optimizations. When you start calling back, especially into Java code from JavaScript, you can sometimes thwart the compiler's ability to see what you're doing. Because the moment you make a call into Java code from essentially nowhere, then the compiler has no information about what types you might or may not be passing. Sorry. In GWT 1.5, simple JavaScript methods are inline, thanks to Bob Vaughter and a lot of the great work he's done. And the final thing to keep in mind is just that JavaScriptObject is still evolving, so the rules are still subject to change. There's several resources you can look at for more information. The GWT doc, obviously. GWT source code is a great example for how to use a lot of this stuff. And then finally, Bob has a JavaScript interop library. It's kind of like JSNI on Rails, so to speak. And you can find that on a Google Code project. And that actually allows for sort of deep integration with various JavaScript APIs without you having to write a lot of code. So if we have any more time, could we take a couple of questions?
Take one burning question.
Oh, actually, if anyone's got a really burning question, mine's not that burning.
Okay.
I can just talk about
Can you please do you want to for the audience?
In the past meeting in the other room, Joel was talking about memory leaks when you use low-level JavaScript. So is this still applicable to here as well when you use the JavaScript object?
As long as you are, well, yes. In fact, that is a danger. In fact, I think the example I gave on one of my earlier slides This one, depending on what that JavaScript is doing on the hood, this is probably a good example of a memory leak that you created unless you have some kind of cleanup code. So yes, if you are using handwritten JavaScript and particularly integrating with other libraries in ways that have like callbacks or events, then you do need to be aware of the memory leak issues because they're real.
Thank you.
Thank you.